Swayam Prabha. Digital India. Educated India.
Till now, we have looked at how to interface with R, define variables, save variables, work with variables, access different elements in structures, and so on. In this module, we will start looking at programming in R, but before we do that, we will look at matrix and matrix operations that are very useful while we program in R. So we'll start with simple arithmetic operations that you can do in R. These are very standard that have been seen before in other programming languages. For assignment, there are two ways of assigning. One is to use an equal to or the symbol that's shown next to the equal to. The other assignment symbols are pretty much the same: addition, subtraction, multiplication, division, and so on. In terms of arithmetic operations, there is a hierarchy of operations that you use in R, which is very similar to how we do normal computations. The order of precedence is bracket, exponent, division, multiplication, followed by addition and subtraction. You can have variables and constants defined in R. There are certain rules that one should follow when variable names are given. There should be no special characters such as exclamation, at the rate of, and so on. All alphanumeric characters, underscore, dot are allowed to be used in variable names, and one should always start variables with alphabets. For example, you cannot define a variable 2b and say that is equal to 7, as shown in the right hand side. There are already several predefined constants in R that can be used in programming. For example, the constant pi is referred to by pi, and months in a year you can directly find out by saying month.name. It lists out all the months and so on. So these are already predefined, so you don't have to define those. If you want to use those in your code, you can directly use these predefined constants in R. Other than the arithmetic operations, most of the programming in data analytics would require logical operations, and the standard logical operations such as less than, equal to, and so on are rather self-evident. And as you see, you have a less than sign for less than equal to sign for less than equal to, and so on. So there are a list of operations, logical operations, that what one could do in R when one does data analytics operations. Now, the key element which we're going to see later in this course in the linear algebra portion is matrices. So matrices form the bulk of most of the data structures, and operations with matrices are very important when we think about data analytic algorithms. So what we are going to do is we're going to show you some simple matrix operations, much like how we saw in list and data frames. We're going to show you how to access different elements of a matrix, how you do matrix manipulations, and how we do computations with matrices. As you all know, a matrix is a rectangular arrangement of rows and columns. The rows run horizontally and the columns run vertically. So if you take the first matrix that's shown on the screen, there are 3 rows and 3 columns. The first row is 1, 5, 3. The last column is 3, 2, 7, and so on. Now, to define a matrix in R, what you need to do is you need to give the sequence of numbers that make up the matrix. So in this example, I have A equal to matrix numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. So when I see this, I know these numbers are the components in the matrix, but I don't know how to arrange them. So the way you do that is by specifying n row and n column. In this case, we have n row equal to 3, n column equal to 3. Basically, we are saying this is a 3 by 3 matrix. What R does is runs through the numbers and fills as many numbers as needed in the first row. Since we need 3 numbers, it fills 1, 2, 3, and then goes to the second row, does 4, 5, 6, and goes to the third row, does 7, 8, 9, and so on. So this is a standard way of defining a matrix in R. Now, once a matrix is defined, you can figure out several things about the matrix. The command dimension of A will tell you what is the size of the matrix. So you see that 3 by 3, it says it's a 3 by 3 matrix. n row of A gives you the number of rows in matrix A, which is 3 in this case, and n columns of A gives you the number of columns in this matrix, which is also 3. There is also another command called length of A, which basically gives you the total number of elements in the matrix. In this case, it turns out to be 9. Now, there are different ways of constructing some special matrices. For example, if you wanted to construct a constant matrix, the first example is here. I have matrix 3, 3, 4. The last two elements are always for the row and column. Second example is to get a diagonal matrix defined. So in which case I give only the diagonal elements and give the size of the matrix. The first case, diagonal element, it's a square matrix, so I give 3 by 3. I've given 3 numbers, 4, 5 and 6. So the R program fills 4 as the first diagonal, 5 as the second diagonal and 6 as the third diagonal. The next command, which is diagonal 1, 3, 4, basically is very similar to the first command, matrix 3, 3, 4. Here I am only filling up one diagonal entry 1, but this is not a square matrix. This is a rectangular matrix. So it's 3 columns and 3 rows and 4 columns. So what R does is it starts with the first diagonal and goes down as much as it can fill up. So after 3 diagonals, there are no more diagonals to go. So this is a rectangular matrix with ones at appropriate places. So this is a simple example. If you are running an R code with this session, you can simply try and create these matrices and understand how matrices are created. Now, once these matrices are created, if you want to access several elements of the matrix, this is a very standard formulation that you use. If I have a matrix which we had defined before 1, 2, 3, 4, 5, 6, 7, 8, 9, and if you were interested in accessing the second number there, which is pointed out in the slide. So number 2 is in first row, second column. So you simply do A square bracket 1, 2 to indicate that you're looking for a number in the first row and the second column of the matrix. Similarly, if you want to access 6, you would simply say A 2, 3. If you want to identify or access a column or a row, this is something that we have already seen before in lists. Very similar idea works in matrices. If I want to just access the first column of this matrix, I do A nothing, 1. Basically it says take every row but only the first column. So I'll get the column 1, 4, 7. Similarly, if you want to access only row 2, then what you do is you say A 2 second row, nothing, which means take every column element. So it gives me the row 4, 5, 6. Okay. So simple example that you can try is how do you access the last row of a matrix. Now there are also interesting ways in which you can pick subsets of the matrix in R. For example, if you take the same matrix again and then you are interested in everything in the matrix other than the second column, what you do is you use this command A square bracket all rows -2. Basically what you're saying is in what you're retrieving, just leave out the second column. So in which case you will get the matrix 1, 4, 7 and 3, 6, 9 as the result of this operation. And very similarly, if you wanted to get everything in this matrix except for the second row, then what you do is A -2. I don't want the second row, but I want every element in the column, which will give you 1, 2, 3, 7, 8, 9. So here is a simple assignment for you to try and do in R. Assign the following matrix, change the element 12 to 13, access the second row and the third column, or list all the elements in second column and third row. These are some of simple exercises that you can do. You can think of other exercises that you can do with this matrix also. Now, when you want to access many numbers in a matrix, so for example, if you have 100 by 100 matrix and you want to access in the third row only columns 5 to 20, there is a very simple way of doing this. Whenever you have a sequence of numbers that would be the indices for which you are looking at accessing the elements, you simply do 1:10. So basically it will say if I do A 3, comma 1 colon 10, it will say third row, every column from 1 to 10, you pick the numbers out. So this is a colon operation which can be used either to get a set of columns out or a set of rows out. You can also get submatrices, many ways of doing this. So here, for example, if I want to just get the first two columns from the matrix, we already saw one way of doing this, which is basically to say A with minus 3 would let out the 369 column. There are other ways of doing it. For example, the first way is to say A, I want 1 colon 3, I want the first 3 rows. 1 colon 2, I want the first 2 columns, which would give you 1, 2, 4, 8, 4, 5, 7, 8. Similarly, you could say, I want all 3 rows, but I don't want the third column, which is minus 3, which is what I just pointed out at the beginning of this slide. So you would get 1, 4, 7, and 2, 5, 8. Or there are other ways of doing the same thing. And pretty much the same thing goes for rows also. You have to keep in mind that you do not have to be constrained to pick rows or columns only adjacent to each other. Here is an example where we have a matrix which is 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's assume that I'm only interested in 1, 2, and 7, 8. These are not adjacent rows, but you could still do this very simply by using this C 1, 3. Basically, it is concatenated and asking for only the first row and the third row. Of those, I'm looking for first and second column, which is given by 1 colon 2. Now, this 1 colon 2 can be replaced by C 1, 2 also, and the result will be the same. So here is an exercise for you. If you wanted to access only this sub matrix, how would you do it? Very similar to the last slide that we talked about.